Hey guys, today we're taking our notes on something called standard deviation. So it's new. They kind of expect you to know it for our first little unit of notes, our first little lesson of notes, unit 111 or whatever. So these are notes, unit 1, standard deviation. So first let's talk about what standard deviation is. I mentioned it in the last set of notes, but it's just a measure of how spread out your data is from the mean. So the smaller the standard deviation, the more clustered the data will be. I'm going to write ST and then DEV for standard deviation. So for example, we looked at like graphing, if you were graphing like a dot plot or something. So if your dot plot looked like this, then that's pretty clustered together. But if your dot plot looked like this, then that is going to have a bigger standard deviation because it's more spread out, less clustered. We're going to look at two different formulas. They're kind of the same thing. One is for a population and one's for a sample. So the population formula. So population means that you know all of your pieces of your data. I'm trying to see the average test score for period 5. I take every single student in period 5's test and I calculate the standard deviation for it. The formula is, this is a Greek letter sigma. We're going to do like a little key. That's a lowercase letter sigma. It's equal to the square root of, and then you have a capital Greek letter sigma, the n on top, I equals 1. And then in parentheses is xi. That just stands for your data piece. So like x1 would be the first data piece, second data piece, so on. Minus mu, that's another Greek letter, squared, all divided by n, but that's under the radical. And then the sample formula is going to look really similar. Sample is if I don't know all of the data. I take just a little piece. So I'm trying to find the standard deviation for period 5's test, but I only take 10 of the 35 students' tests. That would be a sample. So the formula looks similar except for instead of sigma, you use the letter S. You still have that big square root with that Greek letter sigma, n over I equals 1. And then you still have xi, but it's minus x bar squared all over n minus 1, which is still under that radical. So the only difference is that this one's mu, which is the mean for the population. This is x bar, which is just a mean of a sample. Here you have n on the bottom. Here you have n minus 1. So what this whole formula means is you take the sum of, you subtract each data piece minus the mean, then you square each of those pieces, and then you divide that by how many terms there are, and then you take the square root. So I'm going to write down like a little key of what all of those little pieces mean, and then we're going to write down some steps. So our key, so this little Greek letter just means standard deviation. It's the Greek letter lowercase sigma. This is the capital Greek letter sigma. This means the sum of. X sub I just means your data piece. Mu, that just means your mean. N is just your number of data. So those are all of the pieces for this first one, right? You have sigma, capital letter. This one means the sum of, you take each data piece, subtract the mean, square it, divide that by your number of terms. Over here, the only different ones is it has S, which just means your sample standard deviation. And then you have X bar, which is the sample mean. We read it, we say X bar because of the bar on top. Okay, so like I said, this formula looks really big and confusing. So we're going to write down some steps, and these steps are what we're going to use to find our standard deviation. So the first step is going to be to find the mean. That would either be like this one, mu, or X bar. Step 2 is you're going to subtract each data piece minus the mean. Then you're going to go ahead and square those differences. Then you're going to go ahead and add those all together. And divide by n, or n minus 1. By the number of terms of data. That's if you're finding standard deviation or number of data minus 1. And that's if you're doing the sample standard deviation. And then the last step is you're just going to go ahead and square root that result. So for our examples, I'm going to kind of number them so you can see where each of those steps are. Okay, so it's going to be the first picture we take for our digital notebook. You can flip your paper over for our examples. Write down the first example. Find the standard deviation for the sample data set 3, 12, 4, 5. So this is sample, so we're using S, which means that's the one that has the n minus 1 on the bottom. So we're going to go ahead and start with step 1, which is just finding the mean. So to find the mean, you add up all your data and you divide by how many there are. So 3 plus 12 is 15, 19, 24. And then you divide by 4. So 24 divided by 4 is 6. So that's the mean. Step 2, you're going to take each data piece, 3, 12, 4, and 5, and you're going to subtract 6. So you're going to do 3 minus 6, that's negative 3. You're going to take 12 minus 6, that's 6. You're going to take 4 minus 6, that's negative 2. And then 5 minus 6, that's negative 1. So we took 3, 12, 4, and 5, all those numbers, and we subtracted the mean from all of them, 6. Step 3, you square all of those numbers. So I take negative 3 squared. Notice I put parentheses around it because it's negative 3 times negative 3, which is positive 9. 6 squared, I didn't put parentheses because 6 times 6 is 36. Negative 2 squared is 4. Negative 1 squared is 1. Step 4, I'm going to go ahead and add all of those numbers together and divide by, since it's sample, that's n minus 1. So 36, 4, 1, divide by, there was 4 pieces, minus 1. So when I add up 9, 36, 4, and 1, I get 50. So 50 divided by 3. It doesn't divide in evenly. I'm just going to leave it as a fraction because for step 5, we're going to square root that result. So 50 divided by 3, the square root of 50 divided by 3. I'm going to go to my Desmos calculator, do square root of 50 divided by 3. I get 4.082482, but we're just going to do 2 decimal places, so we're going to do 4.08. So 4.08, that was the sample. So we use the letter S instead of sigma. That's our answer. All right, next example, it says find the standard deviation of population of test scores 62, 71, 78, 84. All right, so step 1, we have to find the mean. So we find the mean for step 1. So I got to add together 62, 71, 78, 84. Notice how this one says the population. So that one is sigma. So when we go to like the bottom part, we just do n instead of n minus 1 divided by 4. So I'm going to go get my calculator. All right, so we had 62, 71, 78, and 84. So that's 295. Divided by how many pieces? 295 divided by 4 is 73.75. So that was 295 divided by 4, which was 73.75. So it's a little bit harder. I'm going to need my calculator more than I needed it on that last problem. I'm going to combine sort of step 1 and step 2 together. So I'm going to go ahead and take my data piece, 62 minus 73.75. Then my second data piece, 71 minus 73.75, and then 78 minus 73.75, and then 84 minus 73.75. But I'm also going to combine it with step 3, which is the squaring one. So I'm going to like square all of these answers in my calculator so that I don't have to write down those answers twice. Okay. So I'm going to go to my calculator, I'm going to type in each of my data pieces, 62 minus 73.75, and then I'm going to put parentheses and square it. Then I'm going to do 71 minus 73.75, put my parentheses, square it. I'm going to do my next data piece, which is 78 minus 73.75, square it. And my last data piece, 84 minus 73.75, and square it. So these 4 numbers are the ones that I'm going to write down and for my pieces. Okay. So that was 138.0625, 7.5625, 18.0625, and 105.0625. Okay. Step 4, we're going to add them all together. So I add all of these numbers together. I already did it in my calculator earlier, so I'm going to write down what that was. It was 268.75 when I add all of these things together. And then you divide by, since this is just population, we're just dividing by the number of data, which was 4. So 268.75 divided by 4. I'm going to leave it actually just kind of like that because it's going to be a decimal and it's fine. But step 5, we take the square root of that number. So 268.75 divided by 4. I'm going to use my calculator for that. So the square root of 268.75 divided by 4. I get 8.1967. We're going to do 2 decimal places, but since after the 9 is a 6, it's going to round to 8.20. So 8.20, and that is sigma because it was the population. So on your homework tonight, it's all population standard deviation. Number 3, find the population standard deviation of the data set 21, 30, 42, 38, 27, 31. All right, so to start us off, we need to first find the mean. So we have to add up all of our data. 21 plus 30 plus 42 plus 38 plus 27 plus 31 divided by 1, 2, 3, 4, 5, 6 pieces. So in my calculator, I add those up. I already have it calculated earlier, so it's 189 divided by 6, which 189 divided by 6 is 31.5. So got another decimal one, so when they're decimals, makes it a little bit harder, but we just use our calculator. All right, step 2, we're going to go ahead and subtract. So 21 minus 31.5, 30 minus 31.5, 42 minus 31.5, 38 minus 31.5, 27 minus 31.5, 31 minus 31.5. So 1, 2, 3, 4. Okay, got them all. And then I'm going to combine that with step 3, which remember is the step where I just square it. So I go to my Desmos calculator. I take all of those pieces, 21 minus 31.5, square it. 30 minus 31.5, square it. 42 minus 31.5, square it. 38 minus 31.5, square it. 27 minus 31.5, square it. And lastly, 31 minus 31.5, square it. I think I got them all. All right, and then we're just going to write down those numbers that we got. So it was 110.25, 2.25, 110.25, 42.25, 20.25, and then just 0.25. So for step 4 now, I'm going to go ahead and add all of these together, and then we're going to divide by, since it says population, we're just going to use n, which there was 6 pieces. So when I add those all together, I already added them together in my calculator. I'm just not going to show my work, but you would add all of these, and you get 285.5. And then our last step 5 is take the square root of that. I'm just going to put it as a fraction under my radical, so I don't have to write as a decimal, and that's going to give me my answer. So I go to Desmos, take the square root of 285.5 divided by 6, and I get 6.89, but since the 9 after it is an 8, I'm going to round up to 6.90. And that is sigma for our piece. So it's just kind of a lot of like tedious work. Nothing's like super hard. You're just subtracting, square, add, divide, square root, and you basically use your calculator for most of it, but it just becomes tedious depending on how many pieces of data there are. So these notes going on slide 6 and 7, and then the homework is a Google form.